laws of nature have no inbuilt sense of direction. That's not so obvious. It wasn't obvious to Aristotle, who thought that things naturally fall down. Earth and water fall down, air and fire naturally fall up, go up. But through the work of Newton, it was realized that all directions in space are the same, and the apparent discrepancy is due to the fact that there's a certain large body called the Earth there. But the Newtonian laws of motion exhibit that symmetry. But that was regarded until the 20th century as more or less a nice thing, but not terribly important. The important thing was the dynamics, the forces. It was Einstein, really, who introduced symmetry as a fundamental ingredient as part of the laws of nature. And the symmetry that he particularly implemented was the symmetry that tells you that the laws of nature don't depend on the speed of the observer or the direction in which the observer is moving. He made that a fundamental principle in his special theory of relativity. And he set the 20th century on a path of regarding symmetry as the most reliable foundation for physical theory.
And what's remarkable is where he did it in the macroscopic universe, you're now finding symmetry of laws in fundamental physics to be equally as critical.
But unlike Einstein's symmetry, the symmetry between different ways of that the observer might be moving, we have to deal with symmetries which are broken, where the symmetry is there in the equations, but the solution of the equations don't exhibit the symmetry. And that makes it much harder because they're not apparent, just as the symmetry between the weak and the electromagnetic interactions or the symmetry between the electron and the neutrino were not apparent, but have to be inferred in very indirect ways.
So the great challenge for the future may be to now bring gravity into the unity between all the forces.
Yes, but unfortunately, we have not yet found a symmetry principle that would govern that unification.